Let's look at a few key polynomial factoring examples. Not going to cover everything, but it'll get you a good reminder of how to do some of this stuff for the homework. So there's certain special factorizations that are really, really crucial. So I'd say um, the most beautiful one in some ways is the difference of squares. So any factorization is really going to be coming from a fact about multiplying things. And so if you've got, let me display that. If you've got a plus b times a minus b, if you FOIL that out real carefully, a squared, the first one's multiplied together, okay, and then minus ab, that's the outer terms, plus ba, those are the inner terms, and then minus b squared. Well, minus ab and ba, those cancel each other out, and you get a squared minus b squared. It's nice to not have to do this every time. It's nice to recognize when you see these two things multiplying to know, oh, there's a shortcut, a squared minus b squared. It won't kill you if you always do it this way. It just can waste a little bit of time. But the key thing is going backwards so that when you recognize something that's a difference of squares, you know it factors in a very nice, simple way. So for example, it might not just be variable squared minus variable squared. It might be something like this. It might be 16u squared minus 25v squared. And so you want to recognize, is this really a perfect square in some nice simple way? Is this, oh yeah, they're both squares? Okay. So maybe just as a prep step, 4u quantity squared minus 5v quantity squared. Okay, it is something squared minus something squared. And whatever's in these parentheses, it's going to work. Doesn't matter how complicated, as long as you can write it that way. And so that's going to be 4u plus 5v times 4u minus 5v. It even works if something's already in parentheses, say 2x minus 3 squared minus 4x plus 7 squared. That's going to be a little funky. And maybe a little less likely to see in practice, but you definitely could see something like that. So that's going to be the quantity 2x minus 3 plus the quantity 4x plus 7. Oh, that's supposed to be a plus. Times the quantity 2x minus 3 minus 4x plus 7. That looks a lot more intimidating visually, but the key is the way algebra works, it doesn't matter what's inside these parentheses as long as it fits this pattern. It's one thing, which happens to have multiple pieces inside, plus another, times that first thing minus the second thing. Now, that actually is going to simplify, because now I can say, wait a minute, I can unpack those parentheses. And that's going to turn into 6x plus 4 times minus 2x. Notice the 2x and a minus 4x. And then a minus 3 minus 7. So that's really kind of funky that it turns out to be this. But the main thing is that you've got that difference of squares. So no matter how complicated what the individual squares are, you can use this factorization. Perfect square trinomials, these are things that we've looked at. This is the heart of completing the square, which we'll review again. But that is something that's a good contrast to difference of squares. Here, there is no cross term. It's exactly the case where the cross terms, these guys, where the a and the b were multiplying each other, killed each other. They canceled out. Here, they don't. You're going to get a squared plus 2ab plus b squared when you FOIL it out. Not really different, but it feels different is when that's a negative. The reason I say it's not really different is it's really what happens when you take plus a minus b. But it's nice to be able to just do this very fluently. These guys are ones we really, really want to have memorized as well. Okay, so what about more about factoring? Let's look at sort of a more general quadratic. There's a few techniques here. I want to focus on kind of the least sophisticated one. How would we factor this out? Now, well, I have to mention, not all quadratics factor nicely. It's really kind of artificial how many of them factor nicely in book problems. And we always want to remember we've got a trio of techniques: factoring, completing the square, and when we're solving an equation involving a quadratic, we've got the quadratic formula. And factoring is the one that is kind of gives us the nicest answer in some ways, but is least likely to work because there's just many, many cases where it's not going to work. But let's say, okay, somebody's told us, yeah, I'm pretty sure there's factors. How is that going to work? Well, not that way. There's just a 1 in front of here, and so we don't need any kind of coefficient in front of the x's. We'll do an example, examples in class where you do need coefficient in front of the x's. And then I need these numbers, the constant terms here, to multiply to be minus 32. That's already a clue. So one of them has to be plus and one of them has to be minus. So I'm going to switch that to a minus. And now, so I need two numbers that when I put the minus in, they multiply to be minus 32. So they're going to be factors of 32. And they have to, when I look at, I'm going to get plus one of the numbers from this guy matching with x here and minus the other number matching here. So I need two numbers that are factors of 32. Let's write this down. I need two numbers that are factors of 32 whose difference, because they're coming in with these different signs, is 14. Then we do a little bit of trial and error. Now, 32 is nice because it's a power of 2. The only factors of that are like 2, 4, 8, 16, 32. And it's not too hard to see, 16 minus 2 equals 14. So looks like we're good. We're going to get, let's just copy that. And looks like we're going to get, since we want it to be a plus 14, the one that's matching with the plus, the one with the plus sign is going to be the 16 and then minus 2. That can be tricky. Even if you kind of have it all down, you know what we're going, you really want to double check and just say, let's just multiply that out as if this is the first thing you've ever seen in this problem. X squared, yeah. Plus 16x, yeah. Minus 2x, minus 32. Okay, this is really working. Minus signs are so easy to get wrong. They should always be double checked. Okay, one more, not particularly, not harder, maybe a little easier. So here, but just wanted to see something with different signs. X plus or minus something, X plus or minus something, we're not sure. Oh, wait a minute. They have to multiply to be positive, but they have to add to be negative. Oh, that's going to be that they're both negative, right? How can two numbers multiply to be a positive number and yet add to be negative? That's exactly when they're both negative. And once again, I'm not doing anything where there's any funky factor in front of the x squared. These are just going to be x and x. And that's one of the simpler cases. So we just need these things to be factors of 12 that add to 7. And that's not too hard. X minus 3, x minus 4. Okay, let's just make sure. X squared, so we get a minus 3x. We get a minus 4x. We get a plus 12. Okay, that's x squared minus 7x plus 12. Yay, and we're good.